recording again. Okay. But again, I did send new notes today, so I just double checked they are the ones I sent today are correct. So, all right. Okay, so with outliers, again, those are just data values that are extreme compared to the others. That's where you have a data value that's very big compared to other data values, or it could be very small. It might be very large or very small, that kind of thing. Generally, with outliers, it's very hard to see if they are there, especially if you have a lot of data values, which is why graphing is so good, because graphing makes it a lot easier to see if there are outliers. Again, basically, they're just numbers that appear very far away outside of normal values. That's all. I mean, so from here, maybe from this data set, it might be easy to see that 1 is an outlier. Okay, but it's really easy to see from the graph here, from the histogram, right? You can see most of the data is over here, okay? Whereas over here, there's a data value. So it looks like 1 is an outlier compared to the other data values. So here it's not so bad. You really don't have to graph it to see that 1 is a data value, but you can imagine having hundreds, even thousands of data values. It could be tricky to see which are the outliers. That's why graphing can be so useful. It's kind of like that saying, a picture is worth 1,000 words, so to say. So, from a graph, it's a lot easier to find stuff. All right. Okay. Okay, so that's with distributions. I mean, it is something that we'll come back to. So let's move on, though. We have here what are called measures of central tendency. And basically here, what we're referring to is what we mean by the center. What is the middle of the data set? What exactly is that? That is a little vague. Here's the middle of the data set, or here's the center. Well, what exactly do you mean by that, right? So it is a little vague, and there's different ways of saying what the center of some data set is, or even some distribution, like what would the center be? Well, one way of getting the center, one way of stating the center, that is to use the mean of a data set. The mean of the data set, that by definition is just the average of the data values. Remember, here we're dealing with quantitative data values. I mean, hopefully you kind of saw that already, because we drew histograms. Okay, with histograms, you can only draw them for quantitative data values. So the mean of a data set, again, it's just the average in the normal sense. You add up how many there are, you take the sum, that is, and you divide by the number of data values. That's all, okay? So that's what we can do. So for instance, let's say we had this data set. I put it in a table. Okay. As you can see, to get the mean of this data set, right, we just add up the data values like I'm doing down here. Okay. And we divide by how many there are. The number of them is 8. Okay, so we add them up, divide by 8, we get this number, 43.625. So that's what the mean is, and this is one way of stating the center of the data set. So basically a mean is just an average, that's all it is. All right, that's one example. Well, here's some others. Okay, let's suppose you went to a store and saw the price of peanut butter, okay? I think this might have been an example from the book. Let's say these were the prices. Find the mean price. Well, okay, remember, these are quantitative, right? They're some amount, the amount of cost, that is, how much it costs. Okay, so for the mean, you add them up and divide by by the number of items. Okay, so in this case, we're going to add them up, right? 419, 289, right? And divide by 5 since there are 5 prices. So adding them up, we get $17.91 divided by 5, we get this. So this is the mean price. And yes, I rounded it to 2 decimal places. Okay, so that's, I mean, that's really what mean is, you know, it's just an average. So this is if you have the data set in front of you. But again, we saw that we can display the data using a frequency table, right? Using a frequency table. Now, do we have to list the data and then take the mean that way? No. We can get the mean actually very easily, right? I mean, here, what we can do is this. If we want the sum of the data values, right, we could do 12 times 4, right? 14 times 1, 7 times 5, 5 times 6. And that, of course, would equal the sum. Now, why would that be? Well, if you think about it, if you were to list all these data values out, you would have 12 listed 4 times, right? And 12 times 4 would be 12 added to itself 4 times. Okay, so yeah, that's okay. Same thing with 14. 14 is listed once, right? So you just have 14 on top, which is the same as 14 times 1. 7 times 5, right? You list 7 5 times. Well, if you add it up, right, that sum, which is 35, is the same as 7 times 5. So in other words, for the mean, you add up the data values by just multiplying each one by its frequency. And you do that sum. Now, how many data values are there? Well, that's what the sum of the frequencies are. That's the number of data values. That's what the sum of the frequencies are. You know, you have 4 12s, 1 14, 5 7s, 6 5s. You get the sum. That's how many data values there are. So for the mean here, you have all this. Okay, so here you would get 127 over 16, which is this. So what's nice about a frequency table is you don't have to write out the data one by one, which is nice. You know, it makes it a little bit easier. Okay. Well, let's do another example. So here's another example.